Number 19, the table shows the duration of several eruptions of the geyser Old Faithful and the interval between eruptions. Write an equation that models the interval as a function of an eruption's duration. So the first step in doing that, we want to find out, can we even do it? Is there a correlation? So we'll make a scatter plot. Try to make that line a little straighter. And we always want to label our axes in a real-world situation. So duration in minutes, that would be how long Old Faithful explodes for. And interval in minutes, that's how long until the next eruption. So looking at our duration, they go from 1.5 to 5 minutes. Going by ones, I'll have plenty of space, and if I go by halves, I can be a little more accurate. The smaller the scale, the more accurate you are going to be. 1 minute, 2 minutes, 3 minutes, 4, and 5. So I went by half minutes there. The intervals, we've got a low value of 50 and a high value of 95. So since we skip a bunch of values, maybe I'll skip up to, well, maybe I'll skip up to 50 and go up to 95. So I'm going to go by fives. 55, there's 60, 65, 70, 75, 80, 85, 90, 95, there's 100 minutes between. So if we plot our points, 1.5, 50. 2, 57. There's 55, 57 is pretty close. 2.5, 65. 2.5, 65. 3, 71, right about there. 3.5, 76, right about there. 4, 82, about there. 4.5, 89, pretty close. 5, 95, right there. So you can see there's definitely a positive correlation. Just means that the longer Old Faithful explodes, the longer until the next time it explodes. If I draw a fitted line, this is almost perfectly linear data. I'll try it again here. Something like that. Now when you come up with your equation, you want to pick 2 points on the line. They don't have to be original red dots. The key is that they are on your line. So I'm going to use this point. I can see this nice intersection spot. That's what, 4.590. That color doesn't show up very well. Let's use black instead. And then I'm going to use this nice intersection spot. That's 2.565. So if you want your equation, find your slope, y minus y, over x minus x. And we're looking at 90 minus 65, that's 25. 4.5 minus 2.5 is 2. 25 divided by 2 is 12.5. Your equation starts y equals 12.5x. Because we found your slope, that's the coefficient of x. But now we have to add the y-intercept. And you've got to be a little careful in this one because some people look at this and they go, oh, well, I made a nice graph and it hits down here at, we were going by 5, so -5, -10. Don't forget, though, that we used the heartbeat to skip a bunch of values. So you have to be a little careful because the x-axis is actually, remember we skipped a bunch of values, so that x-axis, there's 50, 45, 40, 35, 30, 25, 20. That's actually way down here somewhere. So what is the actual y-intercept here? Well, work your way backwards. There's 50, there's 40. So we're looking at about 35. So our final answer will be y equals 12.5x plus 35. Now, your answer might vary a little bit, but as long as you're close to those two values, that's a pretty good estimation.